Good afternoon. Thank you for joining us. We're live from San Francisco in RTAI's headquarters, and I want to welcome you all to episode 3 of our little show. Today we have an interesting topic. Today I'm Ishtiyaq Rahman, and with me I have engineer at Archie.ai, Sumit Agarwal.
Hello,
Sumit, thanks for being here.
Thank you.
Awesome. So we have a pretty interesting topic today. The topic is AI and generative models. We're going to try and break it down for you guys and talk a little bit about some of these interesting experiments that are going on around. At the same time, some of the cool things that we have identified and we want to share with our audience. Now, this particular episode is going to be broadcasted in some very niche groups. For example, the Box group, deep learning groups, and if you have any questions and if you want to engage us, please feel free to put it on the comments section. We have our great team here who's looking at that stream and will address your questions. Now, without further ado, I wanna start this conversation by asking Sumit, what is a generative model?
Okay, so you must have seen articles about a machine is able to generate paintings.
Yes.
Suppose like a painting is given, it's able to generate new painting from it, or something like image is given and it's able to generate it is able to give a new season to the pictures. Like
right.
If you give an input as a winter, it is able to convert it into summer picture.
Right. So what you're saying is that you give examples
Yes.
of a particular picture, like winter.
Yeah.
And the AI is able to create an
A
image.
different season for that image.
Okay,
Yeah.
and are these some of these examples?
Yeah, yes.
Okay.
So can you see in this, like there's a winter picture,
Okay.
and the machine is able to give a summer effect to the
Oh, okay. So the machine is able to give it a summer effect of
Right.
the same picture,
Yes.
what it would look like in the summer if you give it enough examples. That's great. I think, so this image on the left was
Is the input image, and the right is the output image for the machine.
okay.
And we can do the opposite, as we can give a summer
Right.
image and we can get a winter image.
Winter image. So
Yeah.
that is sort of like an example of how generative models work. I want to just segue a little bit quick.
Yeah.
I want to like touch base on why it's so interesting with artificial intelligence is because the way we used to write software has changed,
Yeah,
right?
right.
So before it was a lot of if-then logic. You had to give it instructions. Now we're writing software instead of instructions. We're doing examples.
Everything was rule-based before.
Rule-based. Okay.
Yes.
Okay. Talk to me a little bit about that.
So we used to give a particular set of rules, if and as conditions, that if this particular condition is satisfied, this particular method should be achieved. But nowadays, what generative model is able to do is, it is taking it examples such as image examples or video examples or text examples and generating similar objects from the training data set.
Yeah, and I think I want to add to that is that is actually an interesting leap because we actually don't know all the things how we do them, right? So like driving a car, we actually don't know. You couldn't give me actual instructions of actually driving a car or even like do my laundry.
That's right.
Right? So I think that allows us to replicate human behavior like we have never been before, right?
Yeah, we can input real life situations to the machine and the machine can learn it very easily.
Right, that's great. So yeah, moving on from there. So this is one of those legendary experiments that got people's attention because now you see that the bot or the AI is able to make things that are indistinguishable from human creations, right?
There is another example which was recently.
Yes, this is a big one.
Big one, right? This is a video uploaded of Obama giving speech, and it was actually, if you look at the image and the video, it will look like it's a real video as Obama itself is giving a speech. But the interesting part is this.
Given this audio as input,
This video was generated by machine itself. So have a look at this video.
It's been less than a week since the deadliest mass shooting in American history.
our method produces the following output.
It's been less than a week since the deadliest mass shooting in American history.
So this is interesting.
Foremost in all of our minds has
So
been
it's learning the voice of Obama
by the
and
people of Orlando,
it will generate new voices of
Video
Obama.
of Obama saying the same words.
especially our friends who are lesbian, gay, bisexual, or transgender. I visited with the families of many of the victims on Thursday, and one thing I told them is that they're not alone.
To demonstrate the power of the method, we apply the same input speech mapped to 4 different target videos. Note that all 4 are synthetic and have different lighting conditions.
Auto industry. To help families refinance their homes. To invest in things
So
like
as you can
high-tech
see,
manufacturing.
the machine is able to mimic the facial expression of Obama as well as the voice.
Right,
Job training
and-
helps folks
yeah.
learn new skills to
You
fill
can maybe
those
pause it
jobs.
for a second. So yeah, it makes sense. This actually went on Reddit and all these social media on the top because this just showed what you can do with it. You can make former President Obama say anything. Essentially, have anyone say anything if you have enough samples of it. And I think one of the key things you have to understand is that the reason they were able to do Obama's again is because they have so much samples of Obama speaking on public radio and public media. So yeah, this is how can you explain how this is done through a generative model, please,
Sure.
for our viewers?
Okay, so the generative model is composed of 2 neural networks. One is called a generator and another is called a discriminator. So you can tell this generator as a forger who is trying to create fake documents, and discriminator which acts as a police who is trying to find the fake
So 2 entities.
right.
One entity is trying to create fake bills.
Yes.
The other entity is trying to identify
find
the
it.
fake bills.
Yeah.
Okay, how would you make that work?
Okay, I will give you a basic example. So you can see here the generator is and the discriminator.
The fake bill generator.
Yeah.
Okay.
Fake bill generator. Both are at the initial stage,
Right.
and we tell the generator to create a fake money bill.
Okay. They create a fake money bill.
And it's a very basic because it's a learning stage.
It's the first stage.
Yes.
It's very bad. Okay.
And we take that fake generated bill and put it in the discriminator.
So we show it to the discriminator.
The police,
Yes.
basically.
Who is supposed to
Identify.
identify.
Yeah. And since the discriminator is also at a basic level, it tells that this fake bill is actually true, it's real.
Okay.
At that point, we step in and tell the discriminator this is a fake bill, and we will show him a real image bill. So the discriminator will understand, okay, this is not a bill, and I have to modify my parameters according to identify this new bill.
Okay. Makes sense. And
Yeah.
then essentially one entity is trying to fool the other entity.
Yes.
And the other entity is essentially getting better as it plays on with it, right?
Yes.
And I think that plays on to the fact that why is AI so huge today is because we can have these 2 entities go at each other as long as we can afford to. And thanks to cloud computing, AWS shout out, Bluemix shout out. Thanks to these amazing cloud computing platforms, we're able to allow these entities go at each other. And I think I want to mention here because sort of evolution works like that,
Yes.
kind of, correct? So we could be these algorithms, our genetic code could be these algorithms that are continuously fighting the environment to survive and produce better offsprings that have better chances of reproduction. And every time we're having these mutations, sometimes these mutations are cancers and we die. But nature has a lot of scale, so nature can keep doing these things. And essentially, all these generative adversarial networks are essentially, wouldn't you say, mimic the core principles of evolution.
It's basically like you're each and the both models trying to learn each other.
You're right.
Yeah, you're like if you face a new problem, you try to overcome that problem, and that's how you learn how to solve that problem.
You're right.
And then in the future, when a new problem comes, you deal with that problem. You understand how to overcome that problem.
Right.
That's how nature works.
Right. And I think trial and error, which is essentially the basis of every generative adversarial networks, is actually a very effective way of starting a learning process, right? So for example, a kid starts their learning process with trial and error. If you tell a toddler, don't jump off the balcony, it will understand, but it will probably not listen to you until one day it jumps and realizes that, you know, this is not a good idea. So I think in the beginning, knowledge can be transferred into wisdom through experience and trial and error, right? That is the whole idea of the generative networks.
So at the end, what the model, both the generator and discriminator will become an expert in their domain, and there will be, and we can use that expertise in any form.
Right.
So in the later stage, if after thousands and millions of iterations, the generator will be able to generate real images of money. And then we can use this generator or the discriminator in our real life and identify fake notes which are circulating in the world.
Right.
That's a very important feature which we can use.
Right. I hope the engineers who are watching are not going to try to make fake bills. But yeah, that's a great example.
But even if they're able to make a generator, there's a discriminator who's able to find
it. Yeah.
So every evil has a good.
Right.
So,
that's a great point.
Yes.
So moving on from there, I just wanted to talk a little bit about some of the other cool experiments that people can relate to. That we have these models and talk a little bit more about adversarial networks.
Sure. Okay. So one good example is text, creating images from text. So as you can see, if you're trying to describe a particular object, and the computer or the machine is able to generate images from what you're talking about. So if suppose you're describing a bird, so this bird, the person is telling that this bird has a yellow beak.
The bird has a yellow bill.
And it has gray wings. As you tell, the machine is able to generate a similar object image of the bird.
So these were machine created?
Yes, this was machine created and this was given as an input.
Wow. So that is actually pretty incredible. So it's essentially like talking to an artist and telling them, hey, give me a yellow bird with big beak and small claws and very feathery and puffy.
One more application which we can use this is to find if you have seen a criminal and you want to describe the criminal to the police.
Sketch artist.
Yes. As you describe the the criminal face to the sketch artist, the machine will able to generate the image. And we can then just correlate that image with the database and try to find the criminal.
Right. And I wanna mention here that we're giving some examples of these different things you can do with these, but to be honest, when you can create literature and natural variation, the possibilities are limitless, right? So what is this we have right now?
Okay. Suppose you want to draw something, but you're a bad painter.
That would be true. That would be accurate. Yes.
Okay. So here comes the generative model.
Okay.
You just try to draw an outline of a mountain.
Okay.
And the generative model will create a mountain for you.
Wow.
And if you have a white stroke in that between the mountains, it will understand, the generative model will understand that it is a snow.
Wow.
And it will add snow on the painting.
So that's what's happening. This dude just drew the outline.
Yes.
And the generative model, which I assume is trained with all of these images, completes the photo. That is incredible.
It's like a helping hand for your painting.
That is incredible. That's almost cheating. So this is AI coming in, generative models coming into your artistic endeavors, and I think that's really interesting, which is human AI working together to even create art. And I think art is one of the most human things, right? That we can ever do. And I want you to understand if they can do art, they can probably do anything. Now, do you have any other examples for us today?
Sure, yeah.
Okay. What is that?
Everyone loves game, and you want to develop a game for the world.
Okay.
So these are the few images which are taken from various two-dimensional games, and we just fed in the images to the generative model. What the model will do is it will create its own background for the game. So you can see the model is able to generate real life backgrounds for the games, and after a few iterations, you can see it has a different design for your game. So
right, so
yeah.
it's a variation on your game.
Yeah.
You start with something, and your bot creates variations.
And you can use this background for your game. So you don't have to be a designer for a game.
Right, so you can have AI do
Yes,
your games,
yeah.
game design.
Yes.
Okay, that's also another great example. I think it's harder to do art and artistic things. How people and I think if you're gonna have even one takeaway from today's broadcast is that they can do literature. Do you have anything else for us today? Any other examples?
That's it. I think so.
Okay, cool. Well, I think if our viewers, if you wanna extend it any further, you can type GAN, and you can type music, literature. They have written, you can literally give it samples of great literature, and it will produce literature that are essentially similar in styling and wording that it learned from. And I think this is the missing piece. This is the piece that actually does all these really cool tasks that we never thought possible. For example, I think we recently heard New York Times hired an entire team for articles. So they're going to have AI create articles for them, which is pretty interesting. So lots of applications. Today's workshop, we wanted to touch a little bit about what generative models are and what are the basic principles of it, or some of the great applications of it. But in future, we will break it down even more, talk a little bit about how the technologies are built, how it can create and solve some of these complex problems that we face today. Apart from that, today, this is it from us, from Archie AI headquarters. I hope to catch you again day after tomorrow, Wednesday, same time, 4 p.m. from San Francisco. And from here, everybody from here, goodbye and see you soon.
Thank you.